BSides DC 2017 videos are brought to you by Threat Quotient, introducing the industry's first threat intelligence platform designed to enable threat operations and management, and Data Tribe, a new kind of startup studio co-building the next generation of commercial cybersecurity, analytics, and big data product companies.
Hi, everybody. Welcome back. Everybody have a good lunch? Awesome. Full disclosure, I'm a super nervous speaker, so I haven't actually had lunch yet because it would be over there right now. It's also the first time I've ever been given a raised platform, so hopefully I don't fall off of it. That'll be good. So the advice I've sort of been given, and I've been kind of working on my kind of speaking thing over the last little while, and the advice I've been given by the guys that do it more that I work with is always open with a joke. And usually it's something like, why wasn't Walmart hacked? Because it's not a target, right? But it's been a while since the Target hack, and it's less relevant, so I came up with something new, I think. We'll see. You're my test audience. So, directly from their privacy policy, and that was there as of at least yesterday still, so I didn't check today. All right. I hate talking about myself, but I'm going to do it for a little bit anyway. So I'm a senior security consultant at Secure Ideas. I come from a dev background originally. I started slinging code kind of in the late 80s-ish, when I was very young. Progressed into some procedural programming, and then around 97 I started sticking websites up on the internet, and I think starting with GeoCities, and just kind of grew from there. I did 10 years-ish professionally as a web app developer, and 5 as a system integration consultant. So I've got a pretty good handle on kind of the dev mindset, how they think, and what factors influence them. I've got a kind of reputation among my peers for, I don't know, dangerous isn't really the right word, more playful, but for kind of weaving my cross-site scripting payloads into the applications that have the injection flaws rather than breaking the application. And by coming at it that way, you can do some really kind of fun and interesting stuff, like hijacking their AJAX methods so that everything works as usual, but I also get a copy of the requests and responses on my server, that sort of thing. One of my favorite parts of my job, well, first of all, what do I do? Most of what I do is penetration testing and writing the reports for the penetration tests. So there's a good part and a bad part, obviously, right there. Nobody likes reports. In terms of what I test, it's kind of everything. I do a lot of applications because of my background, but I also do internal, external networks, along with the rest of my team. We're a small consultancy, so everybody has to do some of everything, and everybody's expected to develop that generalist skill set. Now, as a developer, I was kind of a generalist anyway, because although I often had full stack responsibilities, I also hopped back and forth between .NET and Java. I didn't really take a side. And that's probably where some of the JavaScript came from. It was the constant and all of that. Now, while I don't like writing the pen test reports, because nobody does, it's not the fun part of the job, but it is the deliverable. What I do like is looking at the different flaws and seeing, well, how can these fit together to augment each other, right? What sort of unique opportunities can I create by using not one flaw, but 2 or 3 or 4 combined? I've got my, I'll we'll move on to the actual topic really soon. I've got my Twitter and email up there, and feel free to take out your phone, take a picture. I don't know, you could follow me if you want. If you have a question afterwards, if you're thinking Wednesday comes around the next week and you're thinking about a web app thing, and feel free to shoot me a question. I don't mind. And same, you can send me a direct message on Twitter. I genuinely like helping people. So, although if I'm on site with a client, I might not have time to respond within, an hour or a few minutes. I will definitely try to answer any questions that I get. Okay. That's enough about me. Should we move on? Yeah. So what am I talking about with forgotten inputs, the title of the presentation? That is right? Yeah, okay. So mostly flaws around missing or insufficient input validation. So should we go back to cross-site scripting a little bit? Maybe, yeah. And it's not always injection, but injection is a common use of this. So there is somewhere that I'm sticking some sort of input, usually in a request, that then gets executed in terms of JavaScript event on the page or just a direct script injection. Is that dangerous? Well, people debate that a little bit. I would say definitely a resounding yes. Examples of the things I can do with it: potentially steal sessions, steal data that's going in and being exchanged with the server, which it's more likely to be kind of in a persistent state, even if it's not stored in the database. Now, my script, if I've executed it on a single page app, until somebody navigates away, that's, the damage is done. I could fake a session timeout and convince you to log back in on a form that looks like the right one and is actually hosted on the right domain, but sends credentials to me and then shows you your app back, just like you logged back in. I could prompt you to install a browser plugin. Now, to be fair, if it's in the Chrome Web Store, there is a degree of code review on that. But I could probably also social engineer somebody into turning on developer mode and installing a plugin unsafely. I mean, if you look at Facebook right now, well, not right now, but today, at any point, you go to Facebook, pop open the developer tools in your browser. And if you don't know where they are, find them, because it's good to know where they are. Pop them open while you're on Facebook, you get a big warning because people were successfully convinced to pop open the developer tools and copy and paste a cross-site scripting payload, I guess, kind of, into their own browser. They're attacking themselves, basically. So it was a big enough issue that they had to put a great big warning in there on Facebook. They actually have big red letters. Don't paste stuff in here if you don't know what you're doing. So this is where, it's important to safeguard anything that is user input. And developers, they're not dumb. Do I have any developers in the room? I'm not going to insult you anyway. I got a few. Not a small number. They're not dumb. If it's supposed to be user input, they will almost always safeguard it pretty well. On newer applications. Some of the legacy ones, not so much. What they, in my experience, and on a large scale, what they're not good at, a lot of them are not trained in security at all, or security issues. They're just, I did work with trading systems that were doing, hundreds of millions of dollars in transactions a day, maybe billions in some cases. Never had secure coding training provided. I had anti-money laundering training provided all the time, but not anything about dealing with code flaws. And so sometimes there are gaps in knowledge that cause mistakes, but that's not really what we're focused on with this talk. Mainly what I'm focused on is the sort of stuff that just gets overlooked, and a lot of that is down to deadline pressure, that sort of need to push things forward to get it within the sprint or hit a certain milestone in a waterfall project, if anybody does those anymore. And I mean, that causes things to not be as thorough as they could be. And even if you have a dedicated QA department, there are certain things that they usually don't test. They're not trained to look for them. So for the most part, it's stuff that is not the fields on the form. Those are user input for sure. The values, in a lot of cases, that you're setting in code somewhere, you're not expecting the user to touch, or rather the developer is. It's funny, I actually have a lot more developers in this room. The last time I did a version of this talk, it was aimed at developers specifically, and I had like 2 developers in a room this size. Anyway, yeah, so stuff, yeah, hidden fields, for example, the HTML inputs that are type hidden. They're not there for the user, but the user has access to them, and either through playing with them in the dev tools in the browser, maybe running script on the console, or using the man-in-the-middle proxy if you're doing a pen test usually. Those can be manipulated. So they're not actually necessarily safe, but often the validation on them can be forgotten. Parameters in the URL, and that's not limited to the query string, and we'll talk about some of the other types of parameters that can be in the URL, kind of this sort of the first thing up. But that's an example of is an area where there are a variety of things the user has some control over. The last one actually is often kind of inputs, but not. User-selected values where perceived limitations exist is a broad term that I used for it. But so you get something like a select list, right? You're either picking an item from a list or a drop-down. And you're presented a list of human-friendly values, and behind that there are a list of IDs kind of attached as well, the actual values that get sent when the form gets submitted. A lot of times people don't think with their applications about making sure, they'll test in some cases that I was expecting a state, let's make sure it's one of my states sometimes. But if they forget that, they've probably also forgotten, well, somebody just changed the value to an injection of some kind and is attempting an injection. File names are another one. And file names are, on this list, probably the highest success percentage. If I have a place where I can upload a file in an application and it gets displayed to, I mean, from the standpoint of an attack perspective, probably another user would be more relevant. I would say certainly greater than 50% of the time there's an injection flaw there, using some really creative file names. So that's actually going to be probably my last example, because I think it's my favorite one to finish on. But let's move ahead into the address bar and move from there. Before I get to that, so I worked a project at one point. It was an integration project. I came into it late, so a lot of the development was done, but I was doing a lot of performance testing. And this is about to become relevant to the next slide, but not really to the topic, but it's a fun one to talk about. This was in a bank, big, kludgy, kind of conservative organization. They're important, but they're not agile. So I was doing these performance tests and generating charts, and they liked that. And it didn't really matter that we had basically performance tested, optimized, and didn't need to do anymore. For months, I was just asked to go back, do some more testing, add some more charts, update the report so that it could go to the higher-ups, because they like pictures. So I included some pictures today. There's no, it's an arbitrary division that I kind of made up in my head. There's no statistic statistical support for this. But what do you call that? Evidence that is anecdotal. Yeah, it's kind of anecdotal. So the areas of concern, when you know you have an input field, you know, the biggest thing is, does it work the way it's supposed to when people do what they're supposed to do, right? Because that's the real task you've been given. Gracefully failing with bad input is important too. Like if somebody were to make an error. And I've given the green sliver I put there is you know, is a reasonable amount of effort goes into, probably in a lot of cases, into treating input as hostile or potentially hostile, at least in a web application. As soon as it's supposed to be coming from a trusted source, that whole thing kind of shifts on you, because it's coming from your own database, an API you control. It's coming from somewhere where theoretically the work has been done. And I think those are places where I just haven't seen the same amount of attention to, well, it could be a bad value, because it shouldn't be a bad value. It could be a hostile value. Well, there's no reason hostile data should be coming out of there. But that's kind of the way it seems to be. And again, there's a reason there's no actual unit of measurement labeled here as well, because I don't know what the appropriate one would be. Thoughts per minute, maybe? I don't know. So what is user input? Also, I just pulled this off the internet. I don't know that university or anything like that. Just disclaimer. But yeah, so it's sort of an example, though, a relevant example. You get these fields that definitely are coming from somebody who is filled out to submit the form, right? The organization code, the org name, an amount of money, a big text field for description, some signatures. And then you get in the corner here, you have this office use only section, right? And what's the input control on that? It's a person, right? A person looks at it. But it is part of the form, and anybody filling out the form could also check and approved, write the date in, make up some initials, and submit it somewhere. Other than the person checking it, there's no reason to think that would get caught. And when it's a web application, it's not a person checking every request that comes in, right? It's the actual technological controls. Also, if this was being submitted and then digitized somewhere, I could write something on the top or on the side, and it would take no time at all for people to not remember where it came from or who wrote it there. So moving up to the address bar, kind of getting back on topic a little bit. So there's a bunch of stuff. It tends to get some attention. I would say I see problems in the address bar less often than I do injection flaws in file names, for example. But it does get forgotten sometimes, or it'll be an otherwise secure app with one thing not quite right. Mainly three kinds of input that you see, not counting the HTTP method, because it's not actually in the bar. So you got the query string, which I think I'm probably in a room full of people that all know what the query string is, but I'm going to say it anyway. So in this example, the goto equals /profile. It's the parameters for the GET request that come after the question mark, or usually it's a GET request that uses them. They're route parameters. So when you see something that is, say, my domain /users/42, and it pulls that user's profile or whatever, that would be an example probably of a route parameter. And again, probably the number of developers in the room, probably most people know how that works, but it's going to a routing function in behind the scenes or class. That goes, okay, this is going to the route users with an ID attached, and it extracts that ID and uses it as a parameter. It's part of the framework on the server side. Or it can happen on the client side as well, which is part of what brings us to the next one, the hash or anchor. So you get the URL. And this is sort of in a way, a holdover from earlier kind of internet where often it was a big document with very little formatting. Requests at that point in time were a bottleneck, so you didn't want to do any more than you had to. So you would have links around between spots within the same document. That's what that was used for. So the URL hash at the end of it, and there will be an example of that in a bit too, hash at the end of it, and then it was the name of the element that you wanted to basically move to in the browser. But now that's often used in client-side routing. Like if somebody's doing Angular or I think, well, most of the popular new frameworks have a router available. You don't have to use them, and it's often an optional plugin. But so that same concept of route parameters can also apply client-side now. And it'd be whatever the endpoint is, hash, the syntax can change a little bit, but slash the client-side portion of the route that's being handled on the client side. If that is actually being used to trigger API calls, then you're probably better off attacking the API directly, and that's often the case. So one example, and it's sort of, it doesn't have to be a problem. It's not always a problem, but it's often a symptom that there is something to exploit, is just seeing a path in there as a parameter. It could be fine. A common place to see this sort of thing is in the situation where you request a resource and it goes, you're not authenticated, you don't have a session, redirect you to the login page, and then when you log in, usually on the login page you'll have a parameter like this. When you log in, it sends you back to the resource you originally requested. That's how it does it. So, I mean, if you're seeing it used for a redirect, I mean, obviously one of the first things you want to try is, well, can I redirect it to a different site? Can I redirect somebody elsewhere? Which might not seem like a huge deal, but it can be really useful in combination with other flaws. Now, can I get a really quick kind of show of hands? Who would feel comfortable explaining to somebody today, right now, how cross-site request forgery works? Yeah, that's kind of what I thought. It's really pretty simple. If you are logged into, I'm going to pick on Facebook for no particular reason. As far as I know, they don't have such a flaw. But I'm going to pick on Facebook. You log into Facebook. They, as far as I can remember, they're still cookie-based sessions. They give you a cookie. Okay, cool. You go over to my tab, open the link that I sent you. It takes you to a page that I set up on my own server. And that page submits a request of some kind. You're not probably thinking like AJAX in this case because there are more controls around that, but a simple post to your site. Your browser attaches your cookie to that, sends it off to Facebook where I posted it. And if that's a status update request, then it's basically using your credentials to do a status update because that cookie was included. It was never shown to me, but it was still sent from your browser. So going back to the URL thing, I need you to be logged into your site, to this application that's vulnerable to cross-site request forgery for it to work. Well, a way I can do that, if this sort of flaw is present, is to send you a link that goes to your login page with this parameter specified as pointing to my page. You'll go to the site you know and trust. You'll be presented with a login page. You'll log in. It will redirect to my page. This is if it's an open redirect, which is a flaw. You'll arrive at my page with a brand new session on your vulnerable app, which I could then exploit with cross-site request forgery. Another and particularly interesting one I saw on a test probably 6 months ago was it wasn't doing anything in my browser that I could see, but there was a URL up there, and it didn't seem to reject the absolute paths with the full protocol and domain. So I directed it at a site that I controlled, and I got a request on that server, and I got a JSON parsing response in the application. It was specifying an API to call. Within this organization, they were specifying one of their own APIs that they controlled on a different server through this. But as an attacker, I could specify my own server, and then the API call was coming to me instead of them. Now, that doesn't give me anything. That doesn't give me any data. What it does do, if I had, and in this case I did, if there are detailed enough error messages that you can figure out what structure it was looking for, is you basically, I built up a JSON file that was what I was pointing at, hard-coded response, which then introduced my input into a context that was supposed to be coming from their API. So as far as their app was concerned, it was trustworthy. It was getting around safeguards, right? Because they trust data coming from their API. Reflection is another thing to always check for when there's really any kind of input. So, just quickly, reflection. Basically, if I put it in there, does it get written into the document body somewhere? Because if it does, and it gets done in an unsafe way, and that's a critical part of it. Usually we're talking about concatenation. That's the most kind of common unsafe way, but often when you see something injecting through inner HTML, the .inner HTML method on a DOM object, that's potentially subject to it. So does it get reflected? Does it get written into the document body? Could I potentially use it to write my own stuff into the document body? Security controls for this, and I think it's important to talk about the security controls. Part of it's, if I'm working with somebody, I want to be able to not just break their stuff, but tell them how to change it. But also, if I'm working on an attack, I need to be able to recognize whether their controls look like they're implemented right, and that can save me a lot of time not banging on something that I can tell is definitely implemented right. In some cases, maybe they've gone and done something a little bit, they've tried to be too clever. Sometimes that happens. I know I was guilty of it as a developer too. Tried to be too clever, did something different, and there's a flaw in the implementation that can be exploited as well. There's one more case that I've seen that was interesting with a URL in the URL or a path in the URL. And this is in an open source product, LifeRay Portal, Community Edition. It's not the current version. It is a known vulnerability that they publish on their website. So I'm not doing anything irresponsible here. But it supported a parameter where you could override this content and delivery network it was using. By supplying a URL, all of a sudden the static asset requests for the JavaScript and CSS all get pointed at whatever host you specified, which basically is site-wide cross-site scripting, right? Because you download all the scripts they're supposed to have, edit them how you want to, stick them up on your content and delivery network on your server, point it at that. I haven't said it. I think I got ahead of myself and assumed a little bit. When you're exploiting a cross-site scripting flaw that is not persisted in a database or some sort of storage, there is a social engineering element. There always is, right? It's generally a crafted link that you're sending to somebody to get them to click. We'll move on. This one is really hard to read, right? We'll fix that. that's basically what it looks like. So, is anybody familiar with Thycotic? No? It's a privileged access management solution. It's sort of like a LastPass style password store for enterprise. So their current major version is 10 point something. Back in 9 point something, they had this exact issue. They had a structure, an encoded structure in the URL on some of the pages. This is a security company, mind you. I mean, it was essentially it was intended to be a JSON object, but I didn't actually pick apart their client-side code to find out how they were doing it wrong, but the effect is as if they were passing it into an eval function. And the important distinction there is when you use the JSON object in your browser's API, do JSON.parse. If somebody tries to include a function in the object, that'll throw a parse exception. It won't get executed. If you take the same thing, a string representation of the same object, and pass it into eval, that function gets created. So that is an example of unsafe deserialization. Now I have I should say, there are a few live demos. I kind of wanted to have live demos for everything, but some of them don't really look as good as the canned ones, to be honest. For the file one at the end, I definitely have a live demo. You're going to like that one. So, unsafe deserialization. So first of all, this is effectively what was happening. And it's not the only place I've seen that flaw. It's just a particularly noteworthy place to see that flaw. So this is straight out of the browser's console, probably Chrome. I don't know. I've changed browsers a few times or used all of them. So decode URI there, change it to a string representation. And then I used this eval station that assigned it to something. And evaled it, and you can see the object got created, and it's an array with objects that have names and types, right? Like you might use if you were dynamically defining a table structure or something. This is, I'm going to show you two different sort of exploits on it. Hopefully you can kind of see them. Do I have? Yeah, I have an arrow. I'll show you two ways. Usually the second way is going to be the better way, but let's look at this one first. So instead of assigning a type of string, JSON's kind of key value pairs, instead of assigning a type of string, I have assigned an object. I have named it evil object for no particular reason other than to highlight that it's an evil object. I've given it this toString function with a console log statement in it and return the string, and then closed off the object. So you can see the eval runs, the object gets created. If I access that type field, I get back this object. It has a name of evil object. It's the same thing. But if I compare it to a string, well, in this case, I use the triple equals, which quick 2-second JavaScript primer. Difference between 3 equal signs and 2 is with 3 equal signs, the types have to match, or it's automatically a fail. It won't try to do any coercion. And that's why this has worked the way it did. That returns a false because it's comparing the string to this object that's just above. But the next one, using the double equal sign, is comparing the same two things, but it goes, well, I'm comparing against a string. So I'm going to call the toString function to get the string representation of that object so that I can compare it. My toString function in this case is my payload. So as soon as it does that comparison, you can see the XSS logged out there from the execution, and it evaluates to a type of true because it's returned that string to compare to the other string. That's kind of confusing when I say it out loud. The case where you might favor this over the next one is probably when you're actually trying to delay execution. But if you want to execute right away, you've got another option, and a pretty good one. The syntax, I'll draw your attention to it, but essentially JavaScript has a self-executing anonymous function syntax, is I guess sort of the technical term for it. It's usually used for closures. In this case, you see it's got the same function as before, but it's actually what I've assigned to the type. The type part's kind of cut off a little bit, but trust me, it is. So what I've done is I've wrapped that function in another set of parentheses and then followed it with this additional set of parentheses. And that means when that function is defined, it is also called right away. And I could actually pass parameters into it through the second set of parentheses if I wanted to. In this case, I didn't. So as soon as the eval happens, and it needs to get assigned to that type, I guess property, that execution happens. That string value gets returned. That's what actually gets assigned to the type. And you can see down here when the object's expanded, that's it right there. So if I know what value was supposed to go in there, I can make sure that value still goes in there. It's just goes in there after my code gets executed. They sound like they're having a lot of fun next door, don't they? All right. Now, we can't get out of the address bar without talking about jQuery. Let's have a little talk about jQuery. This is stuff that is old. This is stuff that is supposed to be patched, but nobody updates their JavaScript. So we still see it in the wild all the time. Location.hash is one. So this is a JavaScript selector around, or jQuery, pardon me, selector around location.hash, which is, so I talked about it earlier, the hash part of the URL. Now, does anybody remember what a hash means in jQuery syntax? jQuery selector syntax?
Look for the ID.
For by the ID, that's right. So, yeah, it's using that selector to select that the element by IDs is how that would be intended to be used. And cases where I've seen that done are like there's a jQuery plugin for doing a tabbed interface where you can link to specific tabs. And so it uses the hash to specify which tab to display. But there was a flaw, and this was in the 1 dot series. It was up until 1.6.2, which is like I want to say 2010. It wasn't recent. It's just still out there. But this bit of HTML would end up getting created in the document when it runs. It's just a mishandling of input. The funny thing about it is, yes, it was patched in 1.6.3, but anybody using jQuery migrate in production has potentially reintroduced the flaw. It's a matter of opinion, but I would say use jQuery migrate to update your jQuery. Don't leave it running in production. It's sort of a shim, but there's a development version of it. This is kind of random background, I guess. There's a development version of it that alerts of errors and helps you fix the breaking changes. That's probably what people should be doing, but they don't always do what they should. That's the one that is most likely to be a address bar related thing, but if I'm going to mention jQuery flaws, I should mention the other two big ones, which are, in a few versions beyond that, there was the one with the class selector. So any case where it was concatenating some kind of user-controlled input with a dot at the front to select elements of a particular class. And it's basically the same kind of thing. You put in a space, you put in an HTML element, it creates the HTML element. Anybody who's been hanging around OWASP looking at the cross-site scripting list, by the way, is going to recognize that payload because it's an RSnake classic. You can also, by the way, omit the quotation marks completely if you want to do an alert with a number on that one, but I like this better. The other thing that was going for a while, and into several of the 2.jQuery versions as well, which does not mean it's in the newest 1.jQuery versions. It's confusing a little bit that way. So the get shortcut for doing an asynchronous HTTP get, if it had a content type of text JavaScript, it would get executed right away. To issue that request in the first place, you usually are going to need to have some kind of injection flaw anyway. It just makes it easier to load a payload. There are exceptions, though, to that. Every so often, somebody is going to write an application that lets the user supply an arbitrary URL and goes and fetches it. I think it does it safely, but the Swagger, if anyone's familiar with that, it's an API tool for essentially specifying APIs, documentation, generating SDKs, and well, fun stuff with APIs. It's got an address or a bar in the top of the application where you can put in a URL of a JSON spec to pull into it. Now, as far as any version of it that I've seen, it's not vulnerable to this kind of flaw, but it is an example of that kind of use of being able to take an arbitrary URL. Okay. Hidden inputs. We're going to have to pick up the pace here a little bit. Hidden inputs. So hidden inputs, yes, we talked about them. They don't get enough attention. There's one thing that is especially interesting about them. So usually they're set on the server if there's any kind of server-side templating or inlining with something like PHP or classic ASP. But sometimes it also gets reflected from somewhere, or the JavaScript pulls from a get parameter and stuffs it into the value attribute. So looking at this one, considering this, we have a login form. It's got a post. It's got username, password. There's a hidden at the top there that I've said is injectable. I just arbitrarily made that up. There's some way of injecting in that. Now, obviously, we could inject a script. If it's injectable, we could break context and inject a script like usual. But let's pretend for a second that they're using a content security policy. So I can't get script execution. What are my other options here? Anybody see it? No? I close their form, and then I open my own new form. Content security policy will allow it, and I can post their credentials to my own server. All right. Whew. We're going to make it. Okay. Fun with file names. So this is a list of some files I have in a directory. They're fun to upload. They're actually, most of the image ones are pictures of my boss. It's just get his face into the reports as much as possible because he doesn't like seeing his face in reports. And I'm just kind of a jerk and a bad employee. Yeah, so there are those. I'm going to jump over to the actual live demo of that because that's more fun. And it's not going to work from within presentation mode, so we're going to pop out of presentation mode. Hopefully this will work. Come on, come on, come on, come on, come on, come on. Aha, all right, there we go. Okay, so first of all, since we're here, oh man, the low resolution makes it trickier. Okay, I'm gonna give this a shot and see if I can do it right in, oh, there we go, in real time. And ta-da, that's the jQuery one. Oh, that was really fast. Sorry. I'll show you again. There. If you can see it. There's a hash. I did this image. It's the exact same one that was in the slide. Okay. let's move on to the file one, because that one I think is more fun. Hopefully I can find the right file. There we go. There, see, there's Kevin. Kevin, by the way, because I didn't say it earlier, he's pretty well known. Was a SANS instructor. He wrote the web pen testing and advanced web pen testing courses for them originally. There we go. And ta-da! Payload from a malicious server. Yeah, that's right. I forgot to mention that. So this one, it didn't just do an alert that was inlined there. No. This one fetched a payload from another server I was running, and I'll show you that request in a second, and pulled it in and executed it. Why did it happen twice? Anybody know? Any guesses? Because I used the vulnerable jQuery get. So, here we go. Okay, that's a little hard to see. You can see it's kind of, the rendering's a little messed up, but if you can see the bottom window, there's a great big touch command. My cursor's at the end of it, and the rest of the stuff is kind of an artifact. That's the file name. That's where I created it a couple hours ago. What's going on here? Well, what's a hard character to get into a file name? /, right? / kind of screw you for doing anything that involves absolute paths with protocols at the front, or most URLs really. So I stole the one off of the you can see right here, just kind of wraps though, document.location.href, which on the page where it executed is this part. It's the URL. So I stole one of these slashes by substringing it out, and then used it in my GET request to actually write my URL. And you can see, it's got, 1415. Here is the GET request coming into the server. Now, it is running on a port on localhost. It's localhost 8887. As long as the CORS policy is set, there's no reason you can't do this across servers, across different hosts. I just did not want to rely on an internet connection in a conference center at a hacker conference, because that's a bad idea. So that is then my last kind of example. Really? Don't try to connect to the server. That sucks. All right. Oh, come on. I'm gonna get grumpy now. There we go. Haha. There we go. So we got like 3 minutes, but I'll be around afterwards. I'm going to be floating around. I'll actually probably be in here for the next talk, but then I'll be around after that. In a black T-shirt. I won't be wearing the same shirt, so look for a black T-shirt with a red circle with a devil in it. You can always ask me questions then, but we do have a couple of minutes if anybody has a question now. Do I never get? Yeah. All right. I don't get a lot of questions. Thank you.